Greetings, howdy. My name is Nava, and today I'll be presenting about a really exciting project called the Bio-Based Aircraft for Green Aviation, mentored by the one and only Rolanda Perez and Jessica Sinder. This research explores how we can replace traditional drone components with bio-based material made from fungi. And I'll also dive deeper into how fungal mycelium can be used as sustainable biohybrid material for drones. I'll focus on learning about the biology of mycelium, the 3D methods, and how these insights guided the methods and approach to molding components directly into making this drone a possibility. Traditional drone components are often made from metals or composites like plastics that are heavy and resource intensive to produce. Mycelium, the plant-like network of fungi, offers a lightweight, renewable, and biodegradable alternative. Beyond structural applications, its growth patterns and adaptability makes it such a great versatile material for integrating with engineering systems. They are seen to be used on insulation panels as they offer like great thermal insulation. Mycelium being such a great resource, why not use it for aerial equipment to be specific for more sustainable drone fabrication? So this was our what our team project was all about. So mycelium grows in different phases. The young phase is bright white, forming a initial soft-like surface. And the medium phase thickens and develops, brown patches and eventually forms like a rough type of crust. The mature phase is fully dense brown sheet. Once harvested and dried, mycelium becomes stiff and lightweight, while also, remaining its structural integrity. A single station can produce like multiple harvests, making it like a highly efficient, sustainable material source to make something out of it. Replacing plastic parts with drone with fungi material like mycelium, how can this help our environment? Well, swapping out plastic for some mycelium in drones isn't just like a cool science trick experiment, voila. But it can be a leap towards regenerative design. Imagine drone bodies grown from fungi, shaped with agricultural waste, and returned to the earth after use. Sounds recyclable, right? It's lightweight, biodegradable, and of course sustainable. And biodegradable means material that can be broken down by living organisms and turned into natural elements over time. So instead of leaving behind toxic scraps like the phones we don't use no more, just put them aside, we're building technology that can breathe with the planet. So we can apply mycelium to engineering components like drones. Great. But how? To shape mycelium into complex components like drones, we explored different 3D printing methods. It was a long research process. We explored what the probability of maybe producing rigid parts using standard FDM, which stands for fused deposition modeling. Printing the structured parts like drone frames, mounts, but we also found that multi-material printing allowed a stronger integration of soft and rigid areas for compliance and structural support. Then there was also 3D printed scaffolds, which can guide mycelium growth, creating components with precise geometry directly from the source itself, providing that support structure so it doesn't just break. Building on those methods mentioned, our research team developed an approach. Instead of growing sheets and then cutting them, we designed a mold on shape that helps mycelium grow into the shape of a drum chassis. The outer shell holds everything in place while the internal negatives guide the mycelium to form precise mounts for electronics like the battery and the camera. This ensures the accuracy of the dimensions of the drone shape while also maintaining the natural sustainability advantages of the mycelium. Key learnings. This research truly deepened my understanding of mycelium living material. I dove deep into understanding its biology from growth phases and substrate needs to how its property changes after drying. I also gained valuable insights into 3D print techniques that I never knew about and how it guides fungal growth, and also learned in depth the structure of a drone. Looking ahead, we're working to improve how fast mycelium grows and finding ways to strengthen its durability. For me personally, the next big step is getting hands-on with 3D printing and finally begin experimenting with molds. Then comes the fun part, handling the mycelium. I'll have to break up the substrate in the bag regularly or it turns into a rubbery clump that's hard to work with. And working on molds, I would then need to ensure it's securely pressured as that helps the material grow evenly. Then I'll need to keep it moist too because cracks form, the mycelium can actually bio-weld itself back together as long as there's enough moisture. Once it's fully grown, then I want to dry it either in the sun or in the oven until it stops for the growth. First and foremost, I want to thank my mentors and research team whose work inspired me and helped me develop this understanding of mycelium as a functional material. To everyone watching, thank you for your attention. Here's my contact info if you have any questions about this, and adios.